Okay. So we're going to start conceptually. So everybody put your pencils down. I don't want you working with your markers. No drawing right now. Pencils down. Just pay attention. Okay, so let's go back to slope dude. Remember slope dude?
Yeah.
Okay, so what would we call this right here? Puff, puff, positive, right? What about this one? Nice, negative. What about this slope right here? What do we call that slope? Zero slope. Good. And this one? Undefined. So we're going to use that today to talk about excluded values. Okay, take a look at all of these expressions down here. I want to categorize all of these expressions under either zero slope or undefined slope. So if you can see one that you recognize that should go under zero slope or undefined slope, go ahead and raise your hand. Okay, Elgin. 4 minus 4 over 2 is y. You're right, it is 0 over 2, and that's what I'm looking for, but it's not undefined. Why? Because it's 0 over 2. I thought you guys would go for these first. Patrick. Why? Good. Okay, right. You're going straight vertically, up and down, so that's undefined. Okay, so what's the other one that I've got up there? 0 over k. And it's not a coincidence that I use those variables. Take a look at those. OK is 0 slope, and NO, no, is undefined, right? Okay. I thought you guys would think it was funnier than that. All right, so keep going with that. So that one goes here. What do you guys think? Why? Okay, so Giovanni sees that if I have 0 if I plug in 0 or substitute it in for x, it would become 0, and 0 times 6 is 0. So isn't that one undefined? You see it, Vanessa? Even though it would make 0 in the numerator, it would also make 0 in the denominator too. Exactly. If it's 0 in the denominator, it's going to be empty. So where does this one go? 0 slope. Why? So if I take this 2 and plug it into n, it's going to be 3 times 2 is 6, and 6 minus 6 is 0. But what about the denominator? What would the denominator be? 4. So that one is okay, right? Armando. Why? But that's not what makes it undefined. When I plug in the 1, Armando, 1, if m was 1 right here, isn't 1 minus 1 0? So that would make this one undefined. Good job, guys. All right, let's look at these now. So we're going to start really simple up here, and then we're going to go all the way down to this one. So 8 over 2, what's that factored form of this?
4.
Just 4? You guys are going all the way to simplified. How would I factor 8 over 2 to get 4? How do we do it in the warm-up activity? How did we factor it? 4 times 2 over 2, right? That would be the factored form. The 2's cancel. And once we simplify it, it's now 4. Let's do the same thing with this one. Try and factor it a different way. Look at that denominator. Do we need to? Hold on, Anthony. You're right. We could factor it that way, but would that help us out with this 6? Do we need to go that far? Can anybody think?
6 times 12.
There you go. 6 times 12 equals 72. The other answers were correct as well. We want to find the easiest way to factor it, because that's what we're going to be doing today. We're going to be factoring things, but bigger. Everybody see that? Okay, what about this one? Don't need to go that far, though. Look at the denominator. Let's start with the denominator first. Because the denominator can only be factored like this, right? 7 times 7. So how would you factor that 84? See, Cassandra, why you don't need to factor it any more than that? I mean, you really have to look ahead and see where you're going, right? Okay. What about my variables? They kind of just stay what they are, right? Well, right, this is just the factored column, okay? So my 7's cancel, and my x's cancel, and what is remaining? Good. About this last one. Ooh, I've got a star right here. I'm glad I put that there. It was to remind myself, state the excluded value. What can x and z not be? Good. Why, Patrick? Why can x not be 0 and z cannot be 0? What were we doing beforehand? We were finding undefined. What would make this, actually this, what would make this undefined? If the denominator is 0, correct. So if x was 0, wouldn't that make x, if anything is 0, when you multiply it, everything on the denominator would be 0, correct?
Yeah.
So if x was 0, it would make the whole thing 0. If z was 0, it would make the whole thing 0. Okay, we're going to explore this more. Let's look at this one. How could I factor this, Sandra? Good. 2 times 3 over 2 times x minus 1. We call this, I'm trying to think. What do we normally call that? When we, I'm sorry? Not a monomial. Okay, so we call this a quantity. When we call that a quantity, when we're factoring, we want to keep everything multiplying, right? So you wouldn't want to distribute this at all, right? Because then we wouldn't be multiplying again. When you factor, you're dealing with straight multiplication, correct? Okay, so we want to keep the quantity just as it is, inside those parentheses. All right, so what can I cancel from the numerator and the denominator? Good. I can cancel my 2's. So I'm finally left with 3 divided by the quantity x minus 1. But again, I have an excluded value. Raise your hand if you can tell me what my excluded value is. Didn't I just say raise your hand? That's good. Why? If I put 1 in for x, I would get x minus, 1 minus 1 equals 0. Correct?
So basically, like, this value is like the number that gives you 0.
Exactly. It's whatever you put in. Actually, that's what we're going to do next. You guys ready? Okay, so copy all of this down. Okay, so Vanessa, Do you want to come up with a definition for excluded value? You can do it in your own words, yes. You just did it? You said, so an excluded value, an excluded value is something that what? Gives you the result is 0. Specifically in what? The denominator. Good. So that would be an excluded value. Let's clean it up a little bit. So, how about a value that we give a variable that would make the denominator zero. That's pretty good, right? A value that would give a variable that would make the denominator 0. We can all understand that, right? Okay, so let's simplify these and state our excluded values. So how would I factor 12a? Do we have to go that far? I don't think so. There we go. 12 times 4 times, how would I break up that variable?
A squared.
Good job. A squared times A. Cancel my 12 and my A's, and I'm left with, what in my numerator? 1 over 4A squared. What's my excluded value? What can A not equal?
0.
Good job. Okay, what about this one? How would I factor this one? 2 times 3 times x times y. How would I break up that z? Good job. C squared times z. All over. Who's talking to me? Patrick? Okay. What about somebody new? What about Michael? Michael, help me factor the denominator. Okay, I've got an x in the numerator, so let's break up that x squared. So how would I break up x squared? Good. Keep going. Good. Perfect. So my 3's cancel, my x's cancel, my y's cancel, a couple of these cancel. What's remaining? Over xy. All right, what are my excluded values on this one? Raise your hand. Raise your hand. Good now. Okay. Giovanni. X cannot equal 0. Y cannot equal 0. What else? Why z as well? Anthony, why do I have to include z? Because originally it would have made the whole numerator 0, right? I know we ended up here, but when we started, if z was 0, wouldn't this whole thing not even work? Because it would make the whole thing undefined, right? You have to go back to that original equation, or in this is an expression, not an equation. You'd have to go back to the first expression and say, what would my excluded values be before I even start factoring? Okay, let's look at this one. Something should jump out at you, right, Aldrin? What jumps out? What do we call that? That's the difference of 2 squares. So let's factor it. So I've got the quantity m plus 3 in the numerator And I can factor m squared minus 9. Good. M plus 3 and m minus 3. Now I can eliminate my m plus 3. And what's left over? 1 over m minus 3. But we can't forget our excluded values. Before I eliminated my m plus 3, what can m not be? Raise your hand. Explain it to me. Method. What? Why? Okay, so m can't equal 3, because that would make this 0. But remember what I just said about this one? The original equation, we can't have 0 for any of these. So what do you see here? Let me erase this. I originally have m plus 3 times m minus 3. Patrick. It can't be negative 3 either. Let's do it formally. Remember when we were finding zeros, right, with the quadratic equation? What do we do when we find zeros? Didn't we have it something like this, Patrick, where we factored and we had an m plus 3 and an m minus? If I were to say factor m squared minus 3, tell me what the zeros are, how would you do that? You'd factor it this way first, then what would you do? Set them both up to 0. Wouldn't we do that? To find the zeros or the roots? So when I set both of these up to 0, but this time I don't want it to equal 0. So I'm going to say, when does m plus 3 not, I don't want it to equal 0. So how would I solve that? Subtract 3 from both sides. What about this one? Add 3 to both sides. And I get m cannot equal negative 3 and m cannot equal positive 3. Isn't that the same thing we have over here? So the book, when they teach it, they immediately teach you to do this. I taught you how to look at it and know what it means rather than just do what we're supposed to do. Okay, so do both of these make sense? With it? Okay, let's keep going. This one's a little more work. What about this one? We got a factor, right? This is a quantity on here. Let's see if there's a quantity up here when we factor it that makes them cancel. What, Elgin? You already got it? Without even doing an Xbox, you already got it? What two values, when you multiply, you get positive 12, and when you add them, you get negative 8? Good job. What do you guys think? Can you guys see that? What would I do if I did not discover that it was p minus 2 and p minus 6? Off method. Good. Okay. So over p minus 2. What cancels? P minus 2. But before I do that, let's state our excluded values. What can p not be? 2. Good. So this is your answer, guys. P cannot equal 2, and your answer is just p minus 6. That's all that's left over, right? This is chapter 11. So we've got to get through chapter 11, do that CST review every day, do the quadratic formula, deriving the quadratic formula, and then I think you guys will be set for that CST. Okay? We're going to practice it every single day. Yes?
So basically for number 3, it was not p minus 3 and not p3, but it was like m squared.
No, because if we plug or substitute negative 3 back in here, isn't negative 3 plus 3 0? And if I have a 0 times m minus 3, doesn't that make this whole thing 0? Right? What if I made m3? I'm sorry, yes, m3. Wouldn't that make this part 0? and that would make m plus 3 times 0. Doesn't that also equal 0? And we can't have 0 in the denominator. It means undefined. So that's what our excluded values are. When does it make the denominator 0? Because the denominator of 0 does not work because it makes it undefined. Okay? All right, let's move on to whiteboards. Go ahead and put your notes away. And once you guys do this one using your whiteboard. Okay, so looking at this one and going through our steps, we have step 1, greatest common factor. What can I pull out of that numerator? 2. And what am I left with? X squared plus 9x. Good job, Vanessa. She's excited.
I'm so hyper today.
She is hyper today. Okay. The greatest common factor in the denominator. 3. She did good on her quarterfinal. She's excited. Uh-oh. Elgin's feeling neglected. Okay, now what? Other than Vanessa and Elgin? No, that's what me and Patrick were talking about. You can't cross off the x squared, because that's just like doing this, Cassandra. That's like canceling off this. You can't do that.
Why not? So we can't cross off anything?
Can I do that? Can I cross off the 2?
No, we did it right now.
But it's not correct.
So we can't cross off anything?
No. Well, what can I do with this now? I would factor them. Okay, Elgin. Overkill. Okay. Cassandra, how could I factor x squared plus 9x plus 18? It's an x and an x. What two numbers when I multiply makes 18, and when I add makes 9x? X box? You need an X box? What would go in the, what? 9 and, no, not 9 and 2. This is A times C. What goes in the top? 18x squared. What goes in the basement? There you go. Now you can see it, right? 6 and 3. Okay, let's factor the denominator. Remember when we were finding our roots and we would factor out a GCF and I would say, oh, just leave it alone, we don't need it? Well, that's because we didn't need it because we were finding roots. We're not finding roots this time. We still need it out here, so you still have to have those. X minus 4, x plus 3. Good job, guys. All right, and then we're done. You're welcome. X can't be what? Look at the denominator, Elgin. 4 and what? -3. Good job.